Thanks everyone for joining us, even though it's raining outside. Appreciate it. Today, I'd like to share with you our experience in migrating from an on-premises data center over to the AWS Cloud. We only have 45 minutes, so I can't go over every single point in our migration. It actually took about 8 months to complete. But I did want to share with you some of the major challenges that we experienced going from a traditional on-premises to AWS. There are a lot of things that don't translate very well from a traditional data center to a cloud-based solution. And we'd like to share the three main items that was the greatest challenge to us and how we address them going forward. We have a question and answer at the end of our presentation, so if you could please refrain from asking questions until the very end. We have a good 15-20 minutes, so we can go over any questions that you may have about the presentation or any of the technologies that we used during the migration. There's me, the Senior Director of SaaS Operations, Brian Moorhead, which is our Senior DevOps Architect, and Scott Gus, our Senior System Administrator. They'll be covering the more technical components of the migration, while I'll give an overview of the business case and why we selected AWS versus another on-premises data center. So this is some of the list of our customers: retail and consumer, media and internet, technology, energy and transportation, financial media and services, healthcare and education. We do the ATS for 7 out of every 10 .com companies in Silicon Valley. So most likely, if you've ever applied for a job in San Francisco, we have a copy of your resume. So the business case. Data center challenges. We were hosted through Dimension Data, which is a managed service provider in Equinix in Virginia. And we were far outgrowing the infrastructure that was available there. In fact, we had constant issues that led to multi-hour and multi-day outages. We had fixed capacity. We had no elasticity. It was very, very difficult to work with the servers that we had that were sometimes 3 years old. We had long lead time for provisioning. From the moment I signed the sales order, it would take anywhere between 2 to 6 weeks to get a server in. New servers required a 12-month commitment. Every time I ordered a new server, they wanted me to sign a commitment to have that computer for that server for 12 months. If I decided I didn't want it or it was missized, there was nothing I could do about it. We had an aging server fleet with no easy upgrade strategy. It was something that we were caught between a rock and a hard place. And we had such an unstable network infrastructure that our network would continually go down. In fact, this is the network topology that our managed service provider provided us on how our equipment was connected. We, believe it or not, were connected through 26 switches, which caused a cascade and myriad of problems every time a single switch went down. And that's because we had grown so organically within that data center that we were not actually in a single cage. We were spread across Equinix on multiple floors. And we also had a very poor relationship with our service provider. We had gone to the very end of our contract, and they were unwilling to do anything unless we signed another 2-year contract with them. They were not very interested in going month by month. In addition, they offered very poor technical support and monitoring. The traditional data center model I'm very familiar with because I was around during the first .com boom, 1999, where you took the server, you racked them, you stacked them, and you configured them. It was, it took weeks to deploy. And in fact, I remember one situation where I had purchased at double the cost 25 servers that I needed to provision. They were stolen off the UPS truck in front of our company. So those were the days of data centers. And we also had really little visibility in the environments. They had cacti charts, but we didn't have the metrics that we were looking for in terms of CPU, memory utilization, network utilization, and any type of meaningful console that we could use. So we looked at other alternatives. We looked at building out our own data center. We looked at perhaps rack space. We looked at VMware. And what we ultimately decided and came up with is AWS. And the advantages were pretty clear for us. You had instant and infinite capacity without long-term commitments. We could fire up servers at will without any type of commitment, paying on-demand pricing. In addition, we could play around with instance types to decide what the best sizing was for a particular server. That's very hard to do in an on-premises when you purchase a server. It's even difficult if you purchase a very large server and run VMware and try to adjust the resources. Auto-scaling support. This is something that we leverage highly in our new environment to be able to auto-scale servers on demand because of peak load, but more importantly, when a server is misbehaving. There's something wrong with that server. In the old days, we would try to look at that server, we'd try to log into it, try to diagnose the problem. That could take minutes, it could take 30 minutes, it could take an hour. Now, most of our servers are pretty ephemeral. If the server's not working, we just kill it. And then the auto-scale group brings up another server, fully configured, and for our post-mortem, we actually take a look at the log files that are essentially shipped to a syslog server, and we can look at that through Kibana, determining what the problem is. And it's one of those things where we no longer have to wake up in the middle of the night to try to diagnose a problem for a server. We just let it die. And then we have another one come back up tomorrow, and then the next morning, we do a post-mortem on it. AWS services. If you are going to make AWS work for you, you've got to leverage as many AWS services as possible. Why? Because you're replacing servers with services. Servers go down. Most AWS services have a 99.999 uptime availability. We no longer handle email messages. We let SCS do it. We no longer handle notifications or queuing. We no longer have to have an active MQ server and cluster it. We just leverage SQS. We no longer have to worry about trying to get a MySQL database administrator on staff. We now use RDS. We don't even have a MySQL database administrator anymore. Route 53, CloudTrail. The important thing is to leverage as many of these services as possible, because that will lower your total cost when you go to AWS Cloud. Robust API support. They offer a slew of APIs that you can basically extract as much information as you need in terms of EC2 types, what regions they're in, etc. AWS VPC support without dedicated network engineering resources. When I ran an on-premises data center, I had to have a network engineer. Generally, the network engineer, depending on how large my environment was never fully engaged 100% of the time. The other 50% of the time, he was playing Tetris or something else. But I needed a network engineer because I needed someone on staff who knew the nuances of the network. With AWS and VPC, a good system administrator can set up a network, can create the different VLANs, and basically we don't need a network engineer anymore. In fact, even extremely large environments don't require a network engineer anymore. Robust 24/7 support. In the beginning, we were paying for, I believe it was the developer support, which was $50 a month. And that was some of the best support we've ever received from any company. Albeit, it generally took 24 hours for a response, but the response was always very high quality, and it generally went to the root of the cause, or root of the problem that we could work with. Now, obviously, when you went to a full production mode, we actually upped that to the higher class of support. But even that is, I believe, about 8% of total spend. Well worth it. Cost effectiveness through reserved instances, RIs, and AWS services. So if you purchase an RI, you are, for 1 year, you're basically saving about 33% off of your on-demand prices. And actually with today's announcement, where they're offering a total upfront or pay as you go per month, so there's no longer a single down payment. You can save upwards on some of the larger instances just for 1 year, anywhere between 47 and 58%, which is substantial. One thing that I didn't include here is also try to leverage spot instances wherever possible, especially if you're using like a Hadoop cluster or something that is ephemeral, that can just die on you, because with spot instances, sometimes you're paying just 5% of the on-demand cost of an EC2 instance. And again, leverage the AWS services. Why? My company, we're not SendMail experts. We're not ActiveMQ experts. We are a recruiting software company, and that is our expertise. So why should we have to invest resources in trying to figure out how the best queuing systems work or the best mail systems work? Really, it's outside of our area of expertise. Farm it out, and farm it out to a service instead of a server. So the architectural challenges. What were the 3 main architectural challenges? There were several. Before I start, we were located in Equinix in US East, that we were lucky enough to be in a data center that had a direct connect, which is a gigabit link to US East. What that allowed us to do is to have a high-speed link with almost no latency between our AWS environment and our on-premises environment. And what that allowed us to do is we no longer had to worry about the Big Bang approach of moving an entire data center overnight to the cloud. I don't know how many of you have tried to do this, but it's probably the most scariest thing that you can endeavor to do. So with the Direct Connect, what we did was we had the strategy of moving one component after another slowly over from the on-premises to the cloud. In addition, what it allowed us to do is take our database servers, have them replicate to AWS, so that when we were ready to cut the cord, it was an adage of an hour instead of multiple hours trying to get the data synced from a data center over to AWS. So what were the key challenges? First off, it was URI load balancing. ELB is, it's not a very robust load balancing service. It does what it does extremely well, but what we needed is we needed the ability to load balance through the URI, not just by the IP address or a fully qualified domain name. The second was auto-scaling adoption. And we had no concept of auto-scaling on our on-premises data center. So in order for us to be cost-effective, we had to learn what was the best methodology in getting auto-scaling to work correctly. And on top of that, we had the added challenge of trying to auto-scale Windows servers on the .NET platform. AWS wasn't designed to do that. So we had to find methods to do that, not just for our Linux AMIs, but also for Windows. And finally, the NAS migration. The on-premises data center relied heavily on NAS technology. We have on league of 35 million resumes. And each of those resumes have to be converted into a PDF. And we dumped them all in one big NAS volume. So how do we convert that over to S3? That was one of the biggest challenges in the migration. And it's one that if you have a data center, and if you're leveraging a NAS or a SAN, you're going to have to figure out what you're going to do. Whether you're going to use S3 or an EBS volume mounted to an EC2 instance. And that was one of the other big challenges that we had to overcome. So with that, I'm going to turn it over to Scott Gust, who is our senior system administrator, and he will go over the load balancing with the load balancing section, correct? Here you go.
Okay, hi, my name is Scott Gust. I'm Senior System Administrator at Jobvite. I guess the first question is we decided just getting started, what we're going to do is, obviously we were in Equinox, so we decided to go to migrate to US East with our Direct Connect connection. So we had actually set up a VPC, and we had kind of a hybrid environment where any new services would be put into EC2, and all our existing services were still at Dimension Data. And as part of the migration, the new services were set up there, but we still had, when you actually went to the site, it was still going through a load balancer, which was based in the data center. So we actually had to temporarily set up the Nginx relay to route the traffic through the Direct Connect link to our servers that were set up in AWS, and then return back the traffic back through there as well. So we were able to use Direct Connect to do that, and it was very useful for that purpose. We started trying to use the ELBs, and I think let me switch over to the next. Okay. yeah, we started tried to use ELBs, but there was one feature that we needed that was not supported by ELBs. Amazon had promised that it was coming out, but it has not as yet materialized. And that's URI-based load balancing. What that means simply is, say if you have a URL, it's like www.jobvite.com, and then based on what comes after that, / something, it would go to a certain set of servers. So I think the next slide is an example. What we had to do is find a solution that would support that feature. And another thing we also had to do was we had to inject headers into the queries using the load balancer as well, into our responses, into the web pages. So we looked at several load balancer alternatives. Nginx and HA proxy are both open source options, and we evaluated both of those. And we also looked at using F5 AMI, but we decided against that because of the additional costs for that. So Nginx and HA proxy both were potential candidates. So we looked at both of those. So here's an example of the load balancing. We had separate Tomcat pools, and so when you went to URLs like this, like jhire, we wanted to go to a certain set of Tomcat servers, and analytics would go to a certain other set. And we had all these pools were actually set up as auto-scaling groups, which Brian will cover in a minute. But that is what we had to do, and unfortunately, ELBs didn't support that. So we had to come up with something else for that. So for HA proxies, we could actually go ahead and what we did is we ended up creating an auto-scaling group of that, and we have a ELB in front of that. So those are actually managed in the way you would expect Amazon through additional ELBs. Where there's an ELB and there's a group of HA proxy servers behind it. So that allows we're using the ELBs to do that, and the auto-scaling group automatically puts the servers in there. And then when it gets to the HA proxy, we can do the URI matching there, and we can decide to send it to whichever group of servers that we want based on that. So that was our initial approach. Initially we had ELBs, which we had like this setup as well. We had ELBs with servers behind it, and that was our initial approach, where we just had the HA proxy server with the ELB, and then behind that would be the servers. But there was an issue with that. Due to the way ELBs work, they can change the IP addresses that are behind the actual names. So when you launch an ELB, it comes up with an IP address. It comes up with a host name and an IP address, but your IP address of your server could actually change. Unfortunately for HA proxy and actually Nginx, when they initially launch, they do the DNS lookup of the server, and then they don't ever change it again. So if the ELB changes its IP, your HA proxy server ends up pointing at an IP that your server is no longer at, which could be an issue. So let's move on. And also, we're using Puppet as well. So I'll let Brian cover that in the auto-scaling part. But So we had to, at that point, restart HA proxy, which you obviously don't want to do. So what we ended up doing is we have the Puppet, which automatically configures all our servers. And one of the things it does is it installs a register script, which every server runs, and it registers with the central database. So we know all of our servers that we're using. What we do is we generate the HA proxy config every minute, and based on our configuration of all our servers, and by doing a API call to the auto-scaling group to describe the servers and basically generate the correct HA proxy config and automatically install it if there's any changes. So if suddenly we launch 2 more servers, now when you have 2 more servers in our pool, we will then generate a new config with the 2 additional servers, and HA proxy will the Puppet will automatically deploy the config, and it'll HA proxy will be reloaded to take advantage of the new servers. Yeah, so we had a database listed all of our instances. It was just a simple table in MySQL, nothing very complex about it. The CGI servers, the HA proxy servers would essentially hit a CGI on our central server, and it would generate the HA proxy config. The backend section that was generated based on the current configuration. And that's run by every HA proxy and is installed by Puppet. So any change would automatically be pushed out within a minute to our network based on that. So here's an example of the config. So each section would have each server listed individually. And this is all automatically generated every minute based on with like a CGI script that's running. And there's an example of that. All right, I think that's it. So the advantages, we are able to do URI-based load balancing that is not offered by the ELB. And we can actually change the config for each section. For each backend, we can generate additional headers and things like that that we need. Whenever we add new servers, it automatically creates a new config, and there's no downtime or any other issues like that. And so we automatically get access to our new servers. And if any servers go away, then the config automatically takes them out as well. And if in the autoscaling group, if like one dies, the new one will replace it. That's it. Okay, I think that's it. So I'm going to turn it over to Brian.
Hello, my name is Brian. I have to say, before I go into the slides, the migration was fun. I mean, we were sitting in the conference room. We were scoping out all these different technologies. So we're like, where are we going to go? We're going to go AWS. We're going to go Rackspace. And Theo covered pretty much some of the options that we had. But autoscaling was pretty attractive. And it was attractive because it wasn't your standard, ordinary data center. It made you think about things. How are you going to automate these things? And I'm about to get into that, so let me start my slides here. Things we were thinking about were like, in the data center, you'd have to like order a server. You get the server, it's ship, then you got to install your software, or you got to install your operating system, then your software. And back in the day, prior to moving to AWS, we'd rely heavily on the wiki. So you'd have your server administrator, he'd make sure that the server gets installed, he'd pretty much install the operating system, hopefully in the exact same manner. He installed the other operating system on the other server in the same pool. Because if he doesn't, then you have what we call snowflake. You have like a server in the pool that is misconfigured, has a missing host file entry, or maybe some software wasn't installed on that server. There's a lot of manual intervention. Not only that, when we got the server up and running in the traditional data center, you'd have to monitor it too. So we'd have to go and manually monitor it. If we wanted to add another server to the pool, like I said, we'd have to manually log into the load balancer and add another server to the pool. So there was a lot of things we had to think about. So we put together this list, and this list was pretty much the things that we disliked about being in the traditional data center that we can do something about in AWS. So what we wanted to do is, one is we wanted to make sure we didn't care about losing a server. So I know in the traditional data center, you can also not care about losing a server. If you have like 10 servers in a pool, hey, you lose one, you still got 9. But we didn't want to lose a server and only have 9. We wanted 10 again. We want the number to remain 10. So that was something that was a little problematic in the data center, but wasn't so much when we got to AWS because of autoscaling. The next one was scaling up or down. So there's a lot we can do with autoscaling that we haven't done yet. Initially, when we migrated to AWS, we set it up so that we can autoscale up and down, but based on the number of desired instances. So there's a feature built in that you can use. We use usually the CLI API, but you can use the AWS console too, and you can say, hey, I want a desired instance number of 1, 2, 3, 4, 5, 6. So because we were very focused on the number of servers in the pool, and we wanted to make sure we always had that number, during migration, we set everything up so that we always auto-scale to that number. And we were doing that so we can kind of measure the resources that were required on these servers, because if we felt maybe we had too many servers or too less servers, then we can scale up. And we were using the on-demand stuff. We weren't thinking about RIs yet. We didn't want to think about RIs until we figured out the exact size server that we actually needed per instance. So scaling up and down was definitely one of the key things we wanted. The other thing we wanted was consistency in hardware, software, yada, yada, yada. In an auto-scaling group, when you scale up or scale down, you make sure that everything's built identically. Operating systems configured identically, the configs identically. I'll get to the config soon because that doesn't come out of the box. We had to implement some config management solutions. And you also want your application deployed in a consistent manner as well. And last but not least is the acceleration of the server, introducing new servers to your farm. And as Theo was describing earlier, it was literally taking weeks. And if it was the wrong size server, hey, then you got like 2 4-core servers and 1 8-core server in the same pool. And then you can't really balance your load very well because one server is a lot larger than the other servers. So we started with auto-scaling, and because we didn't know, we saw that it was interesting, but we didn't know a lot about it, so we had to talk to a lot of AWS architects. We had to figure out how are we going to start, and they're like, all right, so for for auto-scaling, you're going to pretty much start with your user data, and you're going to set up some bootstrapping scripts. So we're like, all right, what is user data and what is bootstrapping? And they're like, oh yeah, it's just like a script that launches when you start your server up. We're like, okay, great. So auto-scaling groups, new server comes up. When it comes up, here's the things that we get to define that we want to perform on the launch of any new server. So we came up with this list. We said, all right, one, we want to make sure that we have our own Jobvite repo, which I'm not going to go into too much detail, but we set up a Jobvite repo in S3. So we have our own dedicated repo. And whenever we have new RPM requirements or dependencies, we push our RPMs into our own repo in S3. So we wanted to make sure all of our EC2 instances can utilize that repo because we had to make sure the server came up and installed the exact same software every time for that particular component. So we prepared the repo, and then we installed Puppet Agent. So I'm sure there will be questions around this later. We installed Puppet Agent. We had the options of like Chef, SaltStack, Ansible, but we decided to go on the Puppet route because we had some technical expertise in the Puppet side, and we were in a rush to migrate out of that contract. So we went down the Puppet route. The third thing we wanted to make sure we got was a host name. So we had to make sure when the server was coming up, it was getting a standard host name based on the component. So based on the auto-scaling group, we would get the name, and based on that name, we'd get the component. And the last but not least is LDAP authentication. We wanted to make sure that the users that were logging in previously had the exact same access using their exact same credentials. So we set it up so that all the servers, when they auto-scale up, people can actually SSH into them or RDP into them. So we got that part set up. So these are the 4 main things that we wanted to make sure were done as the server was coming up. The next part was, now that the Puppet agent was installed, was we wanted Puppet to start pushing and installing our software packages that were in our Jobvite repo. So we gave Puppet quite a bit of power because Puppet was really scanning based on host names. So hosts would get their name and they'd get their Puppet agent installed. And when Puppet was running, it would register back to our Puppet server with its name. And well, based on the name, we'd say, all right, install these apps, push these configs, and configure these specific server settings. And then I highlighted the one crons in green because cron actually references what Scott was talking about in terms of a register script. So every server in every one of our auto-scaling groups, when they get Puppet and Puppet installs all this data, it installs a special cron. It installs multiple crons depending on the component. But the special cron is the register script because we need to know about, we want it to know, and we need to know about every server that is registering in our infrastructure. That's the only way we could generate a proper HA proxy config. And that's the only way we can automatically introduce monitoring, which leads me to the next slide. So server's up, it's running all our apps, but it's not being monitored and it's not in the load balancing pool yet. So the register script that I was talking about, that's what Puppet pushes within a minute. So it takes about a minute. So I would say when we auto scale up, it takes about a minute for that server to come up and start registering, or to get Puppet. Then it takes another minute for our register script to kick off. So it's not optimal. I think we can optimize it. Right now it's about a 2-minute process to get a new server, which is much better than weeks. When that server comes up, about 2 minutes in, as Scott was mentioning here, we have a HA proxy, and it's actually hitting an instance that sits on top of the MySQL RDS. This is pretty much our config DB. And our config DB has things like server names, what code to deploy, like what app, what's the revision number. There's a lot of different useful information in this database. And we decided to put that in RDS. So we're running that out of RDS and not on its own MySQL instance. So HA proxy would actually check in with our MySQL database, and it would hit an instance that's not on this slide, but it would be a CGI. We'd get a CGI response back with information that we need. Things like, all right, this particular component, say for example, it's called jhire. Jhire should actually be running, it should be running version 1.8 and branch trunk. And based on that response, we would know what kind of code to deploy, because we wanted to make sure we automated this thing all the way through. We didn't want to have to do any manual installations, manual monitoring, anything like that. So similar to what we did with the HA proxy config, we did the exact same thing with monitoring. So we're using Nagios, but with Nagios, there's a really nice UI that sits on top of it called CheckMK. And CheckMK, not only is it a pretty UI, it's also a means to simplify generating Nagios configs. Because when you're working with the Nagios config, you have to modify like 3 or 4 files. And we didn't want to do that. So we looked into CheckMK, and CheckMK had this nice format where if we just specified a host name, which we knew based off what was registered in our database, Linux, the environment, and then the component name, then we could automatically monitor servers as they were coming up and down. So based off the group name, CheckMK allows you to define what monitors you want running per group name. So if we said, hey, we want like special application monitors to do HTTP checks or URL checks or do a post and see if you get a response, then we'd say, all right, we'll set that up manually. That would be the only thing we do manually. And we're going to set it up one time. And now when these servers are auto-scaling, if they're in that group, they're automatically going to get that monitor as they come up. So some of the advantages here to moving to auto-scaling groups is the automated server launch, the automated server preparation, the automated current version code push, and the automated URI load balancing, and the monitoring. And the fact that as being system administrators, system engineers, when a server fails in the middle of the night, we don't really care. We can sleep through it, wake up in the morning, check Logstash and some of our centralized logging systems, and we can go, hey, all right, so it failed because this, but we auto-scaled back up and now it's just fine. So we don't really care so much about the instance, and we're not having a P1, everyone, like all hands on deck call at 3 in the morning. We just take our time looking into it. We get like another day or two, and there's no pressure. Everyone's happy. So the next big challenge, this one, I should have added more slides. But the NAS was challenging because by default, AWS didn't provide a native NAS. So we had to literally go shopping, looking for different NAS solutions. So Jobvite, we at the time, we actually have more now. At the time we had 8 terabytes of storage on a NAS, and we had 40 million plus files, resumes, attachments, whatnot, anything related to jobs was on that NAS. We were looking at S3, but S3, it wasn't really a NAS, nor did it have any metadata that was equivalent to storing files on a NAS. So we had to do some research to see how we're going to actually migrate our files to S3 and or a NAS equivalent. So we did some research. We went to a few events. In fact, we went to the AWS reInvent every year since it started. And we found Zadara. And we talked a lot with architects and did a lot of research on how we can actually start utilizing S3 buckets. And we liked Zadara for our NAS solution because Zadara had easy access and an easy integration into our AWS environment. So like, all right, no problem, we can work with you, we can get set up, and you guys will be on your way. And not only did they do that, they provided things like the ability to snapshot, the ability to create on-the-fly backups, and the AWS solution that we kind of sketched up, but we didn't do, was to set up an EC2 instance, glue a bunch of EBS volumes together, and pray to God it didn't go down. And we're trying to figure out if we glued all these EBS volumes together, given that right now, or at the time, the EC2 instances, you can only attach 1 terabyte EBS volumes. If we glued all these EBS volumes together and presented it to the file system as a single point, a single mount point, then if any of those EBS volumes went down, how would we restore it? Would you have to take snapshots of all 8 or 10 or 15 EBS volumes? And that was something we didn't want to deal with, which is why we went down the Zadara route for the short term. And we're still using Zadara at the moment now, but we're still looking more into integrating directly into S3.
Hi, I'm Anjit from Malta.
Hi, I'm Brian. So for the NAS, moving to S3 first, we leveraged the S3 Java SDK, and the SDK is amazing. I mean, I'm not just talking about the Java SDK, but when you look at the granularity of the SDK, whether you're talking about the AWS CLI, the Java SDK, or even .NET, because we have some Windows servers running .NET, you can literally do anything, including like launch servers or check your S3 buckets or anything you can possibly imagine that you can do for the UI. You can do more from the command line or from any of these SDKs. You have like total access, total API access to the entire environment. If you're willing enough, you could probably write a script to replace me. But it's pretty granular. Also, there's a Java application that we wrote. So we wrote this Java application to push a bunch of our files to S3. The problem there initially was when we were copying these files, it was kind of slow. And we tried to figure out a faster way to get the files to S3. So we set up multi-threaded copies, and we started thinking, all right, this is still not working. We got one instance, and we're doing these multi-threaded copies, and it's taking forever. Maybe if we increase the instance size, it might help a little bit. It didn't really help. So we're like, all right, what can we do? We sat down with the AWS architects, and we told them about our problem. They got back to us and said, yeah, no problem. You guys can use spot instances. Not only are spot instances great, but they can save you money because you can bid. So we started looking into these spot instance ideas, and we're like, all right, we can bid. We started looking at the bids, and we're like, wow, we can like really bid. We can get an instance, the same instance I was running, that was causing problems getting the copying over for like a fourth of the price, depending on the availability zone that we chose. So we went down the route of actually spinning up, I think, 15 or 20 spot instances. And we it was multi-threaded, and we multi-thread copied on all 15 to 20 instances simultaneously. And we were able to get the 40 million plus files copied over in like 2 or 3 days, it was 2 days. 3 days, which was pretty impressive. Because initially when we were on that first instance, we thought it was going to take months. And we're like, yeah, we don't have months, so we got to get out of this data center now. So this is kind of this is a little picture we drew. This is my mistake. That's actually a direct connect, not a VPN connection. And we got our spot instances up, and we were able to copy from our spot instances, copy from the old NAS based on segments that we specified to our S3 buckets and or Zadara. And we got completely off the NAS and then worked directly with engineers in the process to make sure that our code was referencing the new locations and not the old NAS locations. For the most part, that was pretty good because a lot of it was configurable. So we just updated a config value and didn't have to worry about looking through too much hard-coded references, although there were a few. So some of the benefits that were attractive about moving to S3, and which is why we're still driving towards 100% S3 environment, are that S3, I haven't seen it down, which is great. It's spin up, and where we came from, the data center where we're at, we actually had some downtime. Historically, while we were down, resumes, attachments, they wouldn't be accessible, and it's something that we couldn't afford. So when we found out that S3, not only is it not a server that we have to think about or manage, it's a nice service, it's always up. We saw the service uptime, it became attractive. We decided, yeah, this is where we need to go long term. The other thing is the S3 is actually cheaper than the NAS equivalent, and the S3 buckets are they're cheaper than NAS equivalent, and they're actually cheaper, I think, than our ZR solution. So the other thing we can do that I didn't list here is, and down the line we want to think more about doing, is setting up archival policies, because S3 has beautiful integration into other services like Glacier. So you can even save more money, because Glacier, it takes a little bit longer to get your data out, but if you have log files or things that you're just storing and you're not using, might as well ship them to Glacier and not pay all that additional money, which, like I said, is already pretty cheap to begin with. And I think that's it on the architectural challenges. So I'm going to give this back to Theo.
Thanks, Scott. Thanks, Brian. I'd just like to let you know that our environment, our production environment, is over 200 servers, and we managed to migrate the entire environment with really only 3 system administrators and 1 DBA. And I think that that would only be possible by using AWS and all the services that you can leverage. But on top of that, to overcome some of the challenges, both Brian and Scott came up with some very, very creative solutions. I don't know if a lot of you have had the opportunity to attend reInvent, but it's amazing how, as robust as AWS is, how ingenious a lot of the system administrators are in terms of overcoming these obstacles. And my guys did a great job. How about a round of applause for them? So what were the results after we finally migrated over to AWS? One of the interesting things is, and I hear this over and over, is I like AWS, but it's really expensive. I don't know if we can afford it. And I hear this over and over and over again, and even my CFO was so concerned about the cost of AWS. So when we did the numbers, I crunched them. I worked with our solutions architect as well as our account exec at AWS, and I came up with these numbers that kept saying that, no, it's actually going to be cheaper. No one believed us, and when we finally did the migration, I had estimated the cost, I can't really tell you the exact number, but I hit that number within 2%. And the results were kind of interesting. What does AWS give you? Rapid provisioning. I can provision a server, as Brian has mentioned, within minutes. Not only that, but if I don't like that server, or if I feel that I've undersized it or oversized it, I just restart it with another EC2 instance type. 99.99% infrastructure uptime since we have moved to AWS. Now, a couple of years ago, I know there was a lightning strike US East, and I couldn't watch Netflix for a day. But since then, it's been very, very stable. And there are very few data centers or service providers that can provide this level of uptime. The whole 5 nines is a marketing term. Everybody knows that who's actually in the technical ranks. It doesn't happen. Timely security patching. When Shell Shock, Heartbleed, the XenSource vulnerability came out, they were all addressed very, very quickly. In fact, quicker than probably large enterprises. In fact, the XenSource vulnerability, they did the patches. They didn't even tell us what they were patching, but they did that in the course of just 1 week, faster than any other service provider. Ephemeral ephemeral server support. This is also key. Build a server, blow it away. One of the things that my DBA would do is he would refresh the staging environment with data from our production environment. So he would say, okay, I did a backup of the production database server. I'm going to take down our staging server and do the import. It'll take about 8 hours. And I told him, why are you doing that? Why don't you just bring up another EC2 instance, do the import on that server, and then when it's done, blow away the old staging server. That way, you're only offline for 5 minutes. And it really took a paradigm shift in his thinking, because doing things the old way is so ingrained in even many of us. With ephemeral server support, you can build a server, test it, and then destroy it, and then try multiple scenarios. And that's key to properly sizing servers, and also various different scenarios, like what configuration works best. And you can do this in a very short amount of time. To do this in a data center environment with real servers takes weeks, if not months. Whereas with AWS, we can do it in a week. Services replace servers. I can't stress upon you, leverage AWS services. Everybody thinks that it's the EC2 instances that are the big value add. They're not. It's actually the services, right? Otherwise, why don't you go with Azure? Why don't you go with VMware? It's because these services replace a bunch of servers that are expensive, whereas these services are dirt cheap, right? We send approximately 275,000 email messages a day. Our SCS bill is about 150 bucks a month. Mountains of metrics. We have so many metrics from CloudWatch, CloudTrail, we don't know what to do with them. We store them, and one day we'll actually go and do some data mining, big data, but it's nice to have, especially now that we have so many regulatory requirements to keep all this data, and we have terabytes of data. Now, if we tried to store this in a NAS or a SAN, it would cost us a fortune. Now, we stick it in S3. We can even make it cheaper by sticking it into S3 Glacier, but we'll always have access to the data. And believe it or not, all told, we saved 20% from going from our managed services provider, Dimension Data, over to AWS. No one actually believed that until it actually happened. And in fact, when I was at reInvent, Coca-Cola did the exact same presentation. With their first initial estimates, they thought that going to AWS would cost them 15% more. And then when they did their final migration, it was actually 15% less than what they were paying for their own managed, self-managed on-premises data center.
1.5 or 5.0?
1.5.
That's it.
15%? That's pretty good.
Not for the headache. If what you said, like you're not taking these kind of system integrators, network stuff, I would rather expect them to save at least 80%.
80% over on-premises?
Yeah, that's the only value. For 15%, such a headache doesn't make sense to me. Yeah, 15% is not much.
For 15% of a very large IT budget for a Fortune 500 company is huge. It is significant. Someone got a very, very large bonus in their.
That's just the hosting cost, not the support cost.
Well, this is interesting. So, with all these services, your support staff is actually smaller using AWS than it is using a traditional on-premises data center, right? Because again, I hope there are not a lot of network engineers here. You simply don't need as many or any network engineers. You don't need as many DBAs with RDS.
What isn't taken into account too is the speed of product development as well, not waiting for the infrastructure.
There are soft cost benefits, especially for a company of our growth. We are basically almost doubling capacity and doubling the user base every year. And that's something that if you've ever built a data center, you install a bunch of Cisco 6500 switches, and then when you outgrow those, you have to replace them wholesale again. Whereas with AWS, it's all transparent. So before I go to the question and answer session, Jobvite is hiring. So if you're a senior assistant administrator, DBA, product manager, please come and see me after the presentation. We have some pretty nice things. We got a cup. We got what else do we have? We have a notebook. So we have swag. So at this point, why don't we open up the floor for question and answers?
Maybe you're on Amazon and starts to use all the methods there. So there's some of the lessons that we have.
Yeah, I've often thought about this. So if your environment is fairly fixed, where you're not really growing, and most of your environment you've already amortized in a production environment, you probably won't see as great a cost savings as a company such as ours, where we're continually adding capacity at a rapid pace, 20% a year. In addition, our usage pattern, since we are still predominantly in the United States, we can leverage auto-scaling, where we can turn off machines during low peak periods. But having said that, there's a lot of soft costs to be realized in terms of, instead of hiring man resources to deal with a lot of the components, you can leverage AWS services, right? I mean, RDS is, if you can leverage RDS, it's a huge cost savings because you no longer have to have as many DBAs on staff. They really take care of like the sharp edges for you.
I don't think it has to be really either or though. I mean, there's a lot of people that are deploying hybrid solutions, especially with direct connect. And there's the Ziggo model where like they would release new products up on AWS, figure out what the baseline is, and then allocate the resources in-house to be able to, because a lifetime machine or a system is 3 to 5 years. And I think 3 to 5 years even at reserve pricing is probably more than what the machine costs, especially with VM.
Yeah, with Direct Connect, and also there are regulatory requirements. We constantly have companies that say, we do not want our data residing in the cloud. We want our database locked in a cage somewhere. And in those cases, we are actually investigating doing that, right? Having our application and presentation web servers in AWS, and then having the database server eventually in a co-located environment connected by a direct connect.
The .0 hacks.
Yeah. Yes?
Can you talk a little more about your NAS migration? Like you had the Zadara and the S3. What had to go into what? What were the trade-offs? Why couldn't everything go on S3? Or how did you leverage Zadara?
That's a great question. Our engineering team was not ready to move all the data over to S3. Otherwise, we would have done it. That was obviously preferable. We will eventually completely move all our files off of the NAS, because the NAS, as robust as it is, we've experienced outages because of the Direct Connect outage, and S3 is rock solid. Right? There are issues with S3. Sometimes a lot of people complain about performance issues, reading and writing, but we simply haven't had any issues with that as well.
You mean the engineering on the way to like integrate? It would take time for them to make changes to the code to support S3 versus the traditional NAS. Right? question, but I don't know that much about CloudWatch, but I was wondering what your, why you're still using Nagios if they have these monitoring tools and services.
That's a great question. CloudWatch, other than I think an initial set number of monitors, costs extra to have, whereas Nagios is completely free.
You mentioned issues with Direct Connect. Were those from your data center or more AWS or?
It was a maintenance that AWS had conducted, and supposedly the direct connects that connected us to Zadara, they were redundant, 2 redundant links. For some reason, when one of them was taken offline for maintenance, the other one didn't pick up the traffic. And thus we were completely offline with our network attached storage. I mean, network attached storage, don't use it.
Where was your network engineer?
Yeah.
Playing Tetris.
Do anything with encryption, security, auditing, and looking at like resumes?
This is the bane of my existence. A lot of companies want encryption at rest, which made sense when you had an on-premises data center, but encryption at rest in the cloud makes no sense whatsoever. Who's going to steal the hard drive? Who's even going to know what data resides on what hard drive? And in fact, in the AWS reInvent conference, I didn't realize that the data centers have a red zone. Every drive leaves that red zone, which is the data center. They put it through a wood chipper that basically, it's not demagnetized, it's literally just chips. And so, I don't really see the value in encryption at rest, and I think that those are one of the things that's going to go away. But now, it's something that we have to contend with, and in fact, we converted our MongoDB server, our Redshift server, our MS SQL server to encryption at rest, and we're waiting to move our MySQL RDS server over to Aurora. So that will support encryption at rest just because our customers demand it.
Over to what?
Aurora,
Aurora.
which supports encryption at rest.
Have you gotten a lot of information on Aurora yet?
We have just been granted preview access to Aurora, so we're looking at it now. At this stage, it's MySQL, right? I'm sure it'll evolve in the coming years to try to be a true competitor to an Oracle solution. Yes?
You mentioned you had 200 servers in production. I assume you also run staging and you do your development and testing. Since you guys are cost conscious, how do you manage costs and be sure that instances are right size, you don't have things that are stale, since you're obviously looking at the overall?
That's a great question. So our staging environment is it is a small subset of our production environment, and I specifically undersize all the components so that the engineers have to deal with smaller with less resources. And our development environment was in-house in our server room in our office. We are migrating that over to AWS as well. Again, their development environment comes out of the engineering budget, so I'm not so concerned about that. But staging does come out of mine, as well as production. I think one of the things that is really one of the advantages of AWS is you can continually resize things down, down, down until it stops working. Then you resize it back up. And that's something that we been doing, especially with our database servers, we completely over-provisioned our database servers. And we realized that maybe we shouldn't actually be paying for all these resources that we're not using. But that's one of the flexibilities with AWS is you can constantly change the size of these things until you get the sweet spot. Yes?
I've heard from a couple of my friends that billing is sometimes challenging. Billing don't might get out of hand. So it's kind of a business case that you might be privy to. Is that the same case?
I'm sorry, billing?
Yeah, so billing side of the house when it comes to AWS. Is there any kind of aspect of that?
So dividing the billing is almost like a black science. I look at the bill and scratch my head, and sometimes, for example, I got charged $5,000 for our Direct Connects data out, which is the equivalent of like, how many terabits? I think it was like 60 terabits of data, and there's no way to push 60 terabits of data through a 1 gig link. And I've been going back and forth with our account exec saying that we're not paying for that. And it's also kind of difficult to drill down on a lot of the cost components. I mean, that's why you have third-party companies that are like Cloudability that are trying to help you try to make sense of your bill. And also, if you're using RIs that aren't on 24 hours a day, that's even more difficult to figure out what the sweet spot is. But from what I've heard from our AWS account executive, the Trusted Advisor? Trusted Advisor is coming out with additional tools that will help you kind of optimize what you should be buying in terms of RIs, et cetera. Well, thank you for attending, and my guys will be here, so if you have any questions that you'd like to ask one-on-one, we're happy to stay over and answer any specific questions you have. And thank you.